Our final speaker today, before we wrap it off, and at least some of us head off to the gala dinner tonight, is responsible for Symantec's cybersecurity strategy across Asia Pacific and Japan. You will see him also tomorrow in the Speed Debate Extravaganza to wrap up AusCERT 2017. On the topic of combating advanced cybersecurity threats with artificial intelligence and machine learning, please give Nick Savvides a big round of applause. Nick.
Good afternoon, everyone. Sorry, I have to use my laptop because the fonts didn't work, and I use a lot of pictures and words, as you would expect in a presentation. In fact, my presentations are a little different to what you might be accustomed to. There's a lot of pictures, and I was worried that when I was putting this together that some of my references to the 80s would be lost on the audience, but as I look out over the audience, I'm fairly confident that you will get most of them. So today I'm talking about AI and machine learning. So you might think I'm talking about buzzwords, because they are, but the reality is this is something that's fascinated us since the 50s, but I like to think of the glory days of AI being the mid-80s, because that spawned the best films. Right? We had Whopper in War Games, right? We had sorry, my phone is too far away and I've turned on proximity-based authentication. And every time I walk away from my computer, I get locked out. Debbie, can you just bring my phone up to the front, please? So, we had Whopper in the 80s. Right? This was the only winning move is not to play. We had Deep Thought from Hitchhiker's Guide to the Galaxy, the machine that was supposed to answer the questions of the life, the universe, and everything. And of course, we had the Terminator. And it was the prospect of making these references that made me excited to talk about this topic today, rather than the topic itself. But the reality is this is what captured our imagination. And since that time, we watch terrible TV shows that have all sorts of AI in them. Right? The best one, I think, is, I don't have any prizes, I'm sorry. Does anyone want to just yell out what this one is? You can see down the bottom. I should have put the image credit as a build. This is KIT, right? Now the reason I use KIT as an example is KIT from Knight Rider. KIT, first of all, was a very campy computer, but it was artificial intelligence. And why is KIT artificial intelligence? Well, KIT really had the ability to imitate human behavior. That's what artificial intelligence requires. It requires the ability to perceive, to perform cost-benefit analysis, right, and make decisions autonomously. Now compare that to, say, a system in a vehicle which would form part of an AI vehicle, right? Something that detects pedestrians, because you don't want your vehicles running people over. This is machine learning. This is not artificial intelligence. Right? Now, machine learning is where we are applying most of this type of technology in cybersecurity today, not AI. I'm going to make some predictions later on that you can't hold me to account to in my final slide around AI, but this is really, machine learning is the ability to recognize patterns and understand and self-develop the ability to recognize those patterns. So, and it's really good at doing things like this, like detecting people, because people have a general shape, right? Very easy for machines to do that. It presents challenges though when we talk about cybersecurity, and I'll go through that in a minute, when I compare machine learning to traditional programming. So, traditional programming, right? I write my source code, yeah, and then I get a program out the other side, I compile it, I then add some data, right, and I get my output. Right. Code, program, data, output. This means that we can make decisions around how we're going to structure our applications, how we're going to, we know what we want our output to be, we can apply methods inside our application in the code, and we know that the code is a definitive source of if I want to change the output, I need to change the code. The same doesn't apply to machine learning. The model is different. In machine learning, I take some algorithms, and the algorithms used in machine learning are fairly all open. There is no real competitive difference between people using different algorithms. This is all out of academia. The algorithms I define and the models that I use come out of this. I take the algorithm, I then need to incorporate and train that on data. The data is part of the development of the program. And then I get my output, I get my program. The actual output is the program. It's not my result. I then take data, unlabeled data. So you might notice a distinction. I have some labeled data in the bottom. So this is what we call supervised machine learning. There's two classes of machine learning, supervised and unsupervised. Supervised is where I know my state. There's a ground truth. And this is the easiest type of thing to train on. Right? I know this is bad. Hey machine, look at all these bad things. Hey machine, look at all these good things. And then I show it unlabeled data, and it goes, that data should have this label. And it allows the machine to improve. And it self-learns, and we validate that. In unsupervised machine learning, there is no labels. And that's a harder problem to challenge. And often, in cybersecurity, the way that we apply machine learning is to deal with that unlabeled data. So I get my useful output, I feed back in, everything is good. So just to go back and cover a little bit of history, machine learning is nothing new. We've been talking about this since the 50s. In fact, some of the papers that were written in the 50s around machine learning and early 70s are still relevant today in the concepts. And what I'm going to show, this slide, there's a bunch of stuff that we do at Symantec that uses machine learning, but really what I wanted to use this to show was there was a big fundamental shift in 2006. In 2006, I think, was the democratization of machine learning, right? This is where computing technology, computing power, became effectively cheap enough that we could run deep learning algorithms. And deep learning created an explosion in machine learning. And I have one event up here, which was the Netflix prize. So back in 2006, Netflix said, we're going to run a prize. Here's $1 million to anyone who can build us a better recommender system. Because back then they were still posting DVDs out to people, right? We want to be able to recommend better movies to people. And they ran a prize to do this. And it actually drove a lot of development around machine learning in what we call the deep learning area. It's an evolution of neural networks. And since then, there's been an explosion of machine learning. And pretty much it's used everywhere now. And the main effect that it has is the ability to act as a force multiplier. And I'm going to talk about a non-cyber example. So, has anyone seen this terrible movie? Morgan. Yeah? I saw it on a plane. It's probably the only place that you'll end up watching it. It was pretty bad. But what they did is, because it's like a cyber-engineered organism thing, they decided to partner with IBM, and they were going to make a trailer for this film, and they thought they could get AI to build the trailer, to make the trailer for the movie. AI was programmed in what is good cinematography, how to detect what is an interesting scene. Here are a bunch of trailers from other movies. This is what a good trailer looks like. These are interesting scenes. And then they fed the machine the whole movie. It cried a little bit. And then it selected all the scenes. A human still needed to edit them and sequence them and add music for effect, but it actually produced a pretty good trailer. Now, this would normally take 3 months for a studio. And the interesting thing is this acted really as a force multiplier for them, because There was no ground truth. There is no, this is absolutely a great trailer, right? This is all subjective. And it was done in 24 hours, including the human editing, right? So this is a great example of a non-cyber scenario. And please don't throw things at me for using the word cyber. We have to nowadays. Of an effective force multiplier, taking something and making those people a lot more productive. Imagine how many trailers they could make, or how this could improve the editing process. I did have another slide on some amazing research Disney did, but I was forced to take it out because I only have 20 minutes, and I'd probably talk about this topic for about 2 hours if I could. So let's talk about how this applies to cybersecurity. Well, you'll see how geeky I am because I also have a Rick and Morty sticker on my laptop. The main application is in threat detection in cyber. The ability to be another threat detector. And pretty much everything that you see out on the floor is yet another threat detector, right? And that's what machines are good at. Machine learning is very effective at being a threat detector. But what else can we do with it? What is it being used for today? Well, it's user behavior. Watching a user, this is unsupervised activity, right? Unsupervised machine learning, and looking at someone, the way someone behaves, building clusters of behavior around that, and then giving us an understanding of what that user is doing. And then finally, anomaly detection. Something doesn't look right. This was a very funny scene, Rick and Morty season 1. If you haven't seen it, I recommend you do. It's looking for something different. Why would a Pop-Tart be living in a toaster? Right. Now, these are the 3 big areas that we have that machine learning is applied to today. So let's have a look at these in a little bit more detail. Let's look at threat detection. How does this apply in the threat detection world? Well, it really needs to go from the endpoint, right, all the way through to the network. By the way, that's the Amiga 500, my favorite computer of all time. And all the way from applying machine learning on the endpoint for threat detection and all the way to applying it to our security operations centers, this is what every organization must realize. There is only a limited number of security analysts, right? Machine learning can help you make those people more productive and give them back more time to actually go and do more things. And doing it right is hard because of those models that I was talking about. Some models work very well when I collect a bunch of data and I can run it in a big machine on the network, but those models don't translate well, say, on the endpoint where I have more resource constraints. Right? And then there are models that I want to run on the endpoint which may not make sense on the network because the telemetry and the behavior and my features, right, there's a whole area of science called feature extraction that defines what the machine looks at, may not make sense on the other side. So it's not just about the models though, it's about getting labeled data into it as well. These are all things that need to go into making effective machine learning. So let's look about that threat detection on the endpoint. Well, we can use multiple models, right? Awesome. We can observe many features. Awesome. So what? What does that give us? What does it actually give us? Well, what it does, firstly, is it allows us to protect disconnected environments. Because once I train a model, I don't need to train it, it's not like a signature, I don't need to update it as often, right? It is learning, it has learned and understands how to detect something. It allows us to detect and convict unknown threats, including non-portable executables, so a whole new class of fileless malware, because it can see what it's doing, and it knows those things don't look right. Importantly, it also can provide feedback into other detection systems. So the machine feeds other machines. And eventually you get into this sort of autonomous cycle of self-improvement. Then you get Skynet and, you know. all of the above the top line features there are important for detecting not just APTs, right, but all malware now. And the bottom line features are really important for discovery of new indicators of compromise, right? And getting more value out of our systems, because the machine does this feature extraction and it can now say this feature that we didn't think was important before now correlates to something bad. Go and look for it elsewhere. If we look at it on the network side, well, again, we can use multiple models, but now I can use bigger and more complex models because I have more compute. I can observe many features like I did before, but it also allows me to reinvent a lot of the data that I'm already collecting. For example, if I'm collecting a lot of IPS signatures, some signatures are not relevant, right? You know, these attacks are not relevant to me. Your IPS will filter those out, you collect them, you run them into your SIEM, you do all that sort of stuff, right? But what I can do with machine learning, maybe the machine can figure out that these low informational signatures actually are a secondary indicator for me, right? So I can reinvent my IPS data and I can blend in multiple sources. So I can take in data feeds from different things. I can really supercharge what I'm doing with my SIEM. Importantly, it can help me auto-prioritize human investigations, because humans are going to have to be involved. We have to continue to train the machine. We have to assist it. We have to help it get better, right? And also, the humans ultimately lead the investigations, for now. Right? It allows us to discover unknown breaches. And this is the big one, right? Because we know the time to discovery of a breach is quite long. Hopefully the machine can bring that down. It allows us to discover those secondary indicators of compromise that I spoke about, right? Especially on the network side. This is super important. And I get more from my existing technologies, because I've spent all this money, I have all these investments. It helps me get more out of them because their data is more important to me now, because someone other than a person can look at it at scale. And that's the problem that you have. And again, I can do that autonomous model improvement, which is absolutely critical for the machine to improve. There's a lot more that I can talk about, but like I said, I've only got 20 minutes and I'm probably over, and I nearly am. So I'm going to talk a little bit about how machine learning is being attacked, right? Well, the big one, well, the interesting one is model extraction. Right? Little Shop of Horrors. Yeah? Model extraction. This is where I feed data into the machine, right? Particularly into machine learning as a service type capabilities. I feed data into the machine and I see what comes back, and then I learn the model. And the intellectual property is the model, right? Imagine being able just to reverse engineer someone's source code by making some queries. Essentially, it's the same thing. Now I'm reverse engineering the model. Why do I want to do that? Well, maybe I want to obtain that model for my own purposes and build competing services. No, really, what it's going to do, it's about someone extracting that model and then doing more effective poisoning. Right? So this is where I feed this. I told you, my 80s humour. Right? I see some laughs in the front here. It's poison. The machine, the idea that I can take, if I understand the model, I know what it's looking for, I can poison it and ultimately lead to evasion. Right? I was waiting, anyone get that one? Yeah. Incredible. Anyway, that evasion is ultimately what the attacker wants to do. They want to evade the detection, right? There's a couple of question marks here. It's a tax evasion. There's a guy, $165 million in taxes were evaded. That was the car he bought. The idea is that if I can extract the model, I can poison it, I can evade its detection. If I change my input slightly so that my attacks don't get detected by the machine. And in fact, we can use machines to conduct attack. Because the bad guys also have got machine learning, right? You know? So imagine a scenario where you're doing a social engineering attack as a bad guy, right? And now you want to follow it up with a phone call, right? To go and pressure someone to do a business email compromise. You know, hey CFO, I need you to go say, hey admin, it's the CFO. I need you to pay $1 million to this bank account we've never done business with before, but it has to be done now. Well, imagine I have machine learning now that I have a chatbot that responds to that person in the voice of the CFO and is interactive. It sounds sci-fi, but Microsoft demonstrated that 6 years ago. It's not fantasy. We can be there. And finally, I'm getting to my predictions now. The sci-fi advances will grow. That's where we are. Since 2006, it's really been in the realm of sci-fi. It'll continue to grow at that pace. And it'll move from just detecting threats to predicting attacks. I think that very soon we'll get to the point where the machine will say, I think something's going to happen. You should worry about something. You should worry about this. Because I have seen enough information and I understand enough to tell you that. The worry that I have is once we get into that AI side is if we can't understand the output the machine gives us, we've probably lost control of the machine. So if it tells us an attack is about to happen, and then you ask the machine, why do you think that? And it can't explain to you why, or you can't understand why, more likely, because our brains are small. I think that's where we're approaching actually fairly quickly. So I am over, and my final slide is that every organisation needs to be thinking about how they apply machine learning in all of their operations, because it's not something that is new, it is something that is here now, right? And it's easy to apply. And that's all. Please come ask me any questions afterwards. Thank you very much.
That was wonderful, Nick. Thank you very much. You'll see more of Nick and his appalling 80s pop references tomorrow in the speed debate. Poison, that was Brett Michaels, wasn't it? CC DeVille, Ricky Rocket. Every rose has its thorn. Nick, thank you very, very much. That's the end of today's formal proceedings. Keep in touch during the app. Check the app for all the details tomorrow. If anything does change around overnight, anyone cancels or we move things around, should stay pretty much going according to timetable. Thank you again to our sponsors. A couple of quick bits of housekeeping. If you've booked a seat on the transfer bus for either Gold Coast or Brisbane airports tomorrow, they'll leave from the foyer of the hotel at 5:15. You can store your luggage at the Marriott for the day tomorrow morning. Make sure you do that before you have to check out of your rooms during the day. Gala dinner, pre-dinner drinks will commence beside the pool from 6:30 and we resume at 9 o'clock tomorrow morning. So that's us done and dusted for the day. Another round of applause for our two speakers in the afternoon session, please. That was great, guys. We'll see all of you here since 9 o'clock tomorrow morning and many of you down by the pool at 6:30 tonight.